Hi everyone. So today's lesson we're focusing on how do we find the sum of an arithmetic sequence. So when the terms of an arithmetic sequence are added together, an arithmetic series is formed. So if you look at the example what I've given here, 5, 9, 13, 17, 21 represent an arithmetic sequence. Whereas when you add the sequence 5 plus 9 plus 13 plus 17 plus 21 represent an arithmetic series. So to find the sum of n terms of an arithmetic sequence with a as its first term and L as its last term, we use the formula Sn is equal to n divided by 2 times a plus L, where a represents the first term and L represents the last term. But we can only use this formula when the last term is known. So if we don't know the last term, then we have to use an alternative formula. So we know that the nth term of an arithmetic sequence is given by Tn is equal to a plus n minus 1 times t. So for the sum of n terms, L is the last term, that is Tn is equal to L. So the last term, L is equal to a plus n minus 1 times t. So we're doing this process in order to find the alternative formula if the last term is not given. So therefore we substitute this L. In the place of L, we substitute this expression. So a plus, so instead of L, we write it as, we substitute a plus n minus 1 times t. So we use a curly bracket here. And therefore now we have n divided by 2 times a plus a is 2a plus n minus 1 times t. So we have found the formula when the last term is not known. So we use this formula. Sn is equal to n divided by 2 times 2a plus n minus 1 times t. If the last term is known, then we can use the first formula, which is Sn is equal to n divided by 2 times a plus L. So now let's look at a few examples where we apply this formula. So let me write down an example. Find the sum of the first 10 given terms of the arithmetic sequence for 10, 16, 22, 28, 34, 40, 46, 52 and 58. So we can actually look at this is representing a finite sequence. So we know the last term. The first term is 4 and the last term is 58. We can just use the formula which is Sn is equal to n divided by 2 times a plus L. So now we just have to sub in. So here the question is actually asking us to find the sum of the first 10 given terms of the arithmetic sequence. So therefore, instead of just adding up each terms one by one, that actually takes a long time. It's easier when we apply this formula. So therefore, n is representing, so you're finding the sum of the 10 terms. So n represent 10. As 10 is equal to, we replace n as 10 and a is equal to 4. L is equal to 58. So therefore, we have 10 divided by 2 times 4 plus 58. So now we have 10 divided by 2 is 5. So 5 times 4 plus 58 is 62, and therefore we have 62 times 5, that gives 310. So when we add up all these 10 terms, we get 310. So since we know the last term, we can just use the simple formula. Sn is equal to n divided by 2 times a plus n, and therefore the sum of all these 10 terms given is equal to 310. Now let's look at another example. So second example is the first term of an AP. I'll just write it in short form. Arithmetic sequence can also be called as arithmetic progression. I'll just write it as AP, which is equal to 5. So the first term is 5 and the seventh term is 29. So what is the sum of, find the sum of the first 10 terms of the sequence. The first 10 terms. So how do we find that? So we don't know what is the last term because we are finding the first 10 terms. We know only the first term and the seventh term. So in that case, we have to use the formula, the second formula, Sn is equal to n divided by 2 times 2a plus n minus 1 times d. So for that, in order to apply that formula, we need to know what is the common differences. So therefore, we know what is the first term, a is equal to 5. So therefore, the seventh term, T7, is equal to 29. So therefore, in order to get the common difference, use the term formula Tn is equal to a plus n minus 1 times d. So n is 7 here. Replace n is 7, a is 5, and 7. n is 7, 7 minus 1 times d. So T7 is 29. So in the place of T7, we can substitute 29. So 29 is equal to 5 plus 60. So from here, we can solve for d. So 29 minus 5 is equal to 60. So 29 minus 5 is 24. And 24 divided by 6 will give you d. So therefore, we have d is equal to 4. So we have found what is the common difference. So we know first term is already given to you. So using the seventh term, we have found the common difference, which is 4 here. So now we will find the sum of the 10 terms. So using this formula, Sn is equal to n divided by 2 times 2a plus n minus 1 times d. So replace, so we're finding the 10 terms, therefore n is 10. So 10 divided by 2 times 2 times 5, a is 5, plus 10 minus 1 times d is 4. So therefore we have 10 divided by 2 is 5, 2 times 5 is 10, plus 9 times 4. So make sure that you apply the order of operation. So therefore you have to solve what is there in the bracket first, then multiplication, then addition. So 10 plus 36, and therefore we have 5 times 46, that gives you 230. So therefore the sum of the first 10 terms of the sequence is 230. Just do a quick review of this example. The first term is given to you and the seventh term is given. So we need to find the sum of the first 10 terms. So we have to apply this formula. Sn is equal to n divided by 2 times 2a plus n minus 1 times d. But we have to figure out d using the seventh term. So we just use the general term formula, or otherwise we call it as the explicit rule. So Tn is equal to a plus n minus 1 times d. And therefore we solve for d, which is 4. And then we use the sum formula and substitute the value for n, a, and d. And we have the sum of the 10 terms, which gives 230.